Hello everyone. What we are going to look at today is the solution to today's LeetCode problem of the day, fruit into baskets. But before we look at the solution, let's clearly understand this problem. I would say the hard thing about this problem is the length of the description and not the problem itself. The problem is pretty basic. So let's try and understand the description clearly. In this problem, what we given is fruits array, right? Consisting of a certain number of integers. And each unique integer in this fruits array represents a unique type of fruit, right? And the challenge in this problem is for us to collect as many fruits as possible, but there are some rules that govern how we collect these fruits, right? And let's study those rules. In this problem, what we're doing is basically we're walking from the leftmost point in the array to the rightmost point in the array, like from the start to the finish, and we're trying to collect maximum amount of fruits possible at any instance, okay? But there are certain rules for this. You only have two baskets in your hand. So let's say you're walking down the array with one basket on your left hand and one basket on the right hand, right? So in each of these baskets at any point, there can only be one unique type of fruit. So if I have the fruit with an ID 1 in this basket, I should only put fruits of ID 1 in this basket. And if I have fruits of ID 3 in this basket, only fruits of ID 3 can go into this basket, right? And you can have a million or billion or even infinite number of fruits of the same type in a basket, right? Now, what we're doing is we can like at the end of this problem it would look like we're starting from any tree, but while solving this problem we have to solve from the left to right and find the ideal sequence, right? So what happens is you can keep collecting these fruits and moving on, so on and so forth, but every time you cross a tree you definitely have to collect that fruit, right? So let's say I have fruits of type 1 in my first left basket and fruits of type 2 in my right basket, and let's say I go and encounter a tree with the fruit 3, ID 3, right? I have one here and two here, but the tree says it has an ID of fruit 3, right? Now I definitely have to empty one of these baskets and then take that fruit 3, right? So it's not like I can just ignore a tree and move on and go for it, right? So that's definitely every time we cross a tree, we definitely have to collect the fruit from that tree. Yeah, so these are just the rules, but now what our challenge here is to find what is the maximum amount of fruits collectible, right? And now if you just think about it, this becomes a very simple problem. All they're asking is what is the maximum continuous sequence that contains only fruits of two types. Now why is that? Because let's say you're starting in a particular sequence, right? Let's say this sequence of 2 3 2 2 1 and again a 2, right? So you go 2 3 you can collect, 2 you can collect, again 2 you can collect. So you, let's say you ignore the first one here, and let's say there is a 1 and a 2 here, right? But as soon as you reach a 1 here, you necessarily you can't continue collecting fruits, right? You can't put one in either of the baskets because you have two in one basket and you have three in the other basket, right? So you definitely have to empty one of these baskets. Which basket would you empty? Very simple. So when you collect this one, right, you need to have one basket completely empty, right? So how would you make that basket empty? If you eliminate this 2 and 3, right, from the leftmost side, you only have now two twos left and one basket which contains the fruit 3 is empty, right? So you put one in that basket and then you would go on and continue collecting, right? So definitely this becomes a very simple problem. All they are asking is which is the maximal segment in your array which contains fruits of at most two types. That's it. That's the problem. Or here is a clue for you. Which is the maximum window in your array that contains only fruits of two types. So that is a clue for you. If you've already got the answer, you can go code it out. Or else let's quickly look at the approach and then let's go to the code ourselves. So in this problem, we are going to use a sliding window approach, and initially both my left and the right pointers will be on my 0th index, and I'm going to continue this algorithm until my right pointer falls off the array or goes till the end of the array, right? So let's begin this algorithm. So initially we'll have two baskets, right? My left hand basket and my right hand basket, right? Now what we're going to look at is we're going to look at the element at the right hand pointer, right? So the element here is 1, right? Now I have to check if I can collect this fruit labeled 1, right? I can definitely collect this fruit because both my baskets are empty. So now I simply collect this fruit into one basket, right? Now I have to check is my now how many fruits do I have totally? I have one fruit totally. Is it greater than max fruits? Definitely it's greater than max fruit. So I increment it by 1. I mean, I just take the max of my current amount of fruits and the max fruits and I get that as 1, right? Now what I do is this part is over. Now I shift my right pointer to the next index, right? Now we have to check if we can collect this fruit at the location or one here, right? Definitely I can collect this fruit label 2 because one of my baskets empty. I cannot put this fruit 2 in this basket, but I can put it in this basket. So I have collected this fruit. Now again I apply this max fruits logic. So I have two fruits now, which is greater than my max fruit. So my new max fruits becomes 2, right? Now again I shift my right pointer here, right? Now I want to check. Can I collect 3 in this sequence? Definitely I cannot collect 3 because my first basket consists of ones and my second basket consists of twos. So I cannot put 3 in any of these baskets. Now I'll have to empty this basket. Now this is the key logic. How do we go about emptying this basket? So this will be the logic for emptying this one of these baskets, and it's very simple. You are going to shrink the left side window. Okay, and how do you do that is very simple. You look at the element at the fruits of L, right? So what is the element of the fruits of L here? 1, right? You empty that element. So basically, you empty that element and you increment the L pointer, right? So how do you increment the L pointer? Just by L plus plus. And now you have to check now. Okay, is one of my, now can I put this element 3 inside one of these baskets? Definitely I can put 3 here because now one of these baskets is empty and I can directly put my 3 here. Okay, now this is done. Now I have to check again, is my total number of fruits greater than my max fruits? Definitely not now because I have 2 fruits and there are 2 max fruits. And how do you get the range in this sort of a sliding window problem where you have given L and R? Very simple. You just do R plus 1 minus L, right? So this would give you the amount of elements inside your sliding window, right? That's just for your knowledge, right? Okay, now we finish this 3 part. Now we go to the next, shift the pointer of R to the next element, right? Now we are at 2. Now we have to check, can I put 2 in any of these baskets? I can definitely put 2 here because one of the baskets just contains 2, right? So I'll just add 1, 2 here. Now now again I check what is the total number of fruits I have. So let's use this logic for now. So my L is at index 1 and my R is at 0, 1, 2, 3. Index 3, right? So now if I do 3 plus 1 is 4, 4 minus L is 1, 4 minus 1 is 3. So it tells me I have 3 fruits, which is correct, right? I have 3 fruits in the basket and only by using the index versions I got the same result. So I update my max fruits, right? Now again, I move my right pointer to the next variable, right? In my array. So then what happens is, again I get this element 2, I check if I can put the fruit of type 2 in any of the baskets. I can definitely put because there's this basket here. Then I put all these 3 fruits here. Again I use the same logic, R plus 1 minus L, and I get the max fruits as 4, right? Now I shift the R pointer outside. Now there is nothing to check and I end this algorithm, right? So this is how simple this whole problem is. The only trick here is that in your language you'll have to implement the baskets part, like you can use a dictionary, a hash set or whatever. And the only constraint here is at one time, at most your hash set can have only 2 keys, right? Because 2 keys means 2 unique fruits. And as long as you, like, if you exceed these 2 keys state, you have to bring it down back to 2 key state. That's it. Okay. Now let's look at the code of this problem. So this is the code for my problem and it's going to be really simple. So first what I'm going to do is initialize this max fruits value to 0. The max fruits represents the maximum amount of collectible fruits. Now I need my 2 baskets. So my baskets will be hash sets or dictionaries or whatever you want to call it in the language of your choice. Okay. But basically what these baskets have to do is store some fruits, right? Or store some integers and key value pairs. That's it. So baskets is equal to default dict of int, right? And now that's all I need to do to start my sliding window output. So L is equal to 0 for R in range len of fruits, right? And now, okay, now we have what happens when we go and encounter a particular fruit or a particular tree. Now, let's say I encounter a tree. When do I have a problem of putting that tree's fruit in my basket? Whenever I meet a new tree and I already have my 2 baskets filled, and the fruit on that tree does not match the IDs of my 2 baskets. At that time, what I'll have to do is I'll have to keep emptying the fruits in a sequence until one of my baskets becomes completely empty. So that is the case that we are going to look now. So if fruits of R not in baskets, so the new fruit is not in either of my basket keys, right? So what I have to do is I have to empty these baskets sequentially from the first by incrementing my left pointer until one of these baskets become empty. right? So while len of baskets is equal to 2, fruits baskets of fruits of L minus equal to 1, and then L plus equal to 1. Alright, when before that I'll have to, so if this by emptying this fruit sequentially from the left side, if one of these baskets get empty, right, I can simply like state that this basket is empty and ready for new elements, right? So how do I check here if how many baskets are available? By checking the len of the baskets, which is equal to 2, right? So I'll have to, when a basket gets completely empty, I'll have to eliminate the key or the ID for that basket also before I add the new ID in my baskets. So that's what I do here. If baskets of fruits of L is equal to 0. So when a basket gets completely empty, I'll have to remove that ID of that basket and place the new ID fruit, right? So that's what I do. When it becomes 0, so I do baskets dot pop fruits of L, right? That's it here. And I have to repeat this while loop as long as I don't empty one of these baskets, right? So I'll definitely have to increment this L plus equal to 1. Okay, now we have this ideal state where we are correctly emptying the baskets to add in a new fruit whenever we have a new fruit and we have two filled baskets, right? In all other cases, we can just simply increment, uh, we can simply put the new basket into these, into my new fruit into my basket. So fruits of R plus equal to 1. So either I can empty one basket and put the new fruit, or if that is not the case, I can directly put the new fruit in one of these baskets. So that's all that states. Now, after putting a fruit in a basket, I always have to check if my current total amount of fruits has increased my max fruits or not. So that's what I'm doing here. Max of max fruits, comma, R plus 1 minus L. All I have to do now is return of max fruits and we have solved the problem. So let me just submit it. I'll also post the C++ JavaScript code and Java code in the comments. You can watch it and you can learn. You can also comment whatever you feel like, and please subscribe to this channel. I see a lot of new viewers but very less subscribers, so it would be great if you can subscribe to the channel and also comment on what sort of content you need from the channel. I would love to give it, and I'll see you in the next video. Take care and goodbye.